right, we're still on Chapter 20D. In the first part of Chapter 20D, we talked about quick ways to find the derivatives of polynomial functions. So we talked about the power property, where you can take an exponent and drop it, multiply it to the front number, and then decrease your exponent by 1. And that's a quick way to find your derivative function, which is also called a gradient function, which helps you find the slope of the line at a certain point. So now we're going to do some applications with our derivative functions for different information we can find out. So question 1 says, at what point on the graph of y equals 2x squared plus 5x minus 3 does the tangent line have a gradient of 13? They're asking where the slope is equal to 13. So this is going to be a parabola. We could kind of, right, if we just kind of imagine we have a parabola, we're looking for a point along our parabola where our slope is positive, a very big positive number, really, 13. So, right, probably over there. To do this, we're going to find our derivative function, and then we're going to use that to find where it equals 13. So for my function, it's a polynomial, it's in standard form. To find the derivative function, since it's in terms of y, our derivative is dy dx, like this, equals. We take our exponent, drop it to the front, multiply it with the front number. 2 times 2 is 4. Decrease the exponent by 1. Here our exponent on x would be 1. We do 1 times 5, which is 5. And then we'd have x to the 0, which just is 1, so it's gone. And we can always ignore our constants. So this is the derivative of our original function. We want to know where our derivative function is equal to 13. Remember, the derivative function here, this piece, is the slope at x. So at some point x, right here, maybe at 2 or 5 or negative 6 or something, this over here is going to give us 13. We want to figure out at what point does it give us 13. So to do this, we're going to set that equal to 13. So this is the slope at the point x. We're looking for what point gives us a slope of 13. So I'm going to do 13 equals 4x plus 5. We'll solve for x. This is a quick linear equation. 13 minus 5 is 8. Divide by 4. X equals 2. So at what point, this is the x value of the point. If we wanted to find the y value of the point, we could plug it back into our original equation to find the y value. Also, we could jump over to our calculator. So I love double checking. So I'm going to type my function in y equals 2x squared plus 5x minus 3. Press graph so we can get an idea of what it looks like. There it is. It's a parabola. What we found is that the derivative is 13 at 2. So if we go second calculate and actually find the derivative, so I went second calculate 6. I want it at 2, so I press 2, enter, and it does tell me 13. So that's a good double check. Additionally, we can find the point for this point. So x equals 2 is the x value on the line. My y value would be 15 for my original function. So there's some point on my line at 2, 15 where it has a slope of 13. The tangent line has a slope of 13. The gradient is 13. Our derivative is equal to 13. All those mean the same thing. So 215 is the best answer since it asked for the point. Question 2 says, at what point on this graph does the tangent line have a gradient of 0? So a gradient of 0 means 0 slope. We have a just perfectly horizontal line. It has no slope. So with a parabola, the point that has no slope is that turnaround point. That point right here where it's neither decreasing or increasing. It's like it stalls out for just a second. For just a second, we don't know what it's doing, and then it turns around and it goes back up. This point is where our slope, our gradient of our tangent line is 0. So we need to figure that out. So if you remember all of what I just said, then what you can do is you can just find the vertex. Let's say that you don't. We can do the same method we did above. So I'm going to use that method to figure this out. This was given to me in function notation. So whenever I find my derivative, it'll be f prime of x for the derivative. We take our exponents and drop them to the front. Decrease the exponent by 1, so the 2 would become a 1. It's not really needed. We can just write 2x. Minus, we have an exponent of 1 on that x, drop it to the front, so we have negative 5. It would drop down to 0. That isn't really, x to the 0 is just 1, and we can always ignore our constants. So this is the derivative function for what they gave us. This is my derivative function. I want to know where it's 0. Where is the gradient 0? Where is the derivative 0? Where is the slope of the tangent line 0? Those all mean the same thing. So I want to figure out when this is 0. What value of x gives me a gradient of 0? So 0 equals 2x minus 5. So we would add 5 and divide by 2. What's kind of cool is in our last unit, and you can write this down if you want or you don't have to, it's just something to think about. In our last unit we had this x equals negative b over 2a that allowed us to find the value, x value of the vertex. So if I did that with this function, I would have x equals negative b is negative 5, so it would be positive 5, over 2 times a is 1. So my vertex should be at 5/2, which is the point where our slope is 0. Is at 5/2. Okay. We can use our calculator to help us double check. So x squared minus 5x plus 1 is our equation. Looks like this. We found 5/2, so we can go second, calculate. Number 6, we'll find the derivative, we'll find the slope at 5/2. Enter. Tells me 0. So that checks to make sure we did it correctly. Now you can also see this is the vertex of this parabola. And the last thing is, since it asks for what point, then we need the y value of that point as well. I think the best way to do that is just go to your table. Oh, except for it's at 5/2. What am I thinking? It won't show up in our table. One thing we haven't used a lot, you can do second calculate value, and it'll just tell you your y value. So if you want to do that, you can, or you can plug it back in. But our point is 2.5, negative 5.25. Okay. The next question gives us some information about our function, and it wants us to find a and b. So we don't have the whole function yet. We've got f of x equals 2x squared minus a plus b. We need to figure out what a and b are, and we've got some information. So the tangent of this line at this point, 2, 7, has a gradient of 3. So we've got a slope of 3 at the point 2, 7. So we can start by finding the derivative. We're not really going to know everything in the derivative, but that's okay. So let's find that. We know we're working with gradient. We know slope's going to be involved, so finding the derivative is probably helpful for this. Take my exponent, drop it to the front. 2 times 2 is 4. That would drop from an exponent of 2 to 1. And then we have minus a. The 1 would drop, multiply the a, that doesn't change it. The x would now have a 0 exponent, so it goes away. And we always ignore the constants whenever we do the derivative. So they tell us at the point 2, 7, xy has a gradient of 3. I now have an equation. This is the gradient, this is the slope at some x value. We can use this equation to help us find a. So b is gone because it was a constant. It's not included in our derivative. So we can now plug in This is my slope at x equals 2. We put 2 in for x, and that should figure it out. So the slope is 3 when x is 2. Four times 2 is 8. Subtract the 8 over, and negative a, and then switch our signs. A is 5. So now if we go back to our original function here, we know a is 5. Now this is like our y. We have x and we have b. They gave us this point that's on our line, so now we can take that point and plug it into our equation. So I know that x is 2, y is 7. So my output is 7. My input is 2, so I'm replacing x with 2. And we can find b. 2 squared is 4, times 2 is 8, minus 10. So 7 equals negative 2 plus b. Add the 2. B is 9. So find a and b. We did that. We found both a and b. Now once again, I love to double check. So why don't I plug in a and b and see what type of equation we get? So 2x squared minus a is 5, x plus b was 9. So we get this, it's all the way up there, we get this little graph. Let's see if the point 27 is on it. There it is. In my table, 27 is on that line. Cool. It's supposed to have, at this point, it's supposed to have a gradient of 3. Let's see if that's true. Second, calculate. Number 6 gives us our gradient or our derivative. And we want to do when x is 2. It does, in fact, have a slope of 3 at that point. So I feel pretty good that we found the correct numbers. I found my a and b, plugged them back in, and I saw this point is on that line. Great. And at that point, I do have a slope of 3. All right, last question. The tangent to this equation, with this little fraction in there, at this point has this gradient. So we've got some nice numbers here. We need to find a and b. I'm going to start, since they give me information about the gradient, I'm going to start by finding the derivative. It's in function notation, so we'll use f prime of x. We take our exponents, drop them to the front. So the 2 goes to the front. Drop our exponent by 1. This a is kind of disguised in here. It's just a constant, so it's just a number that we're about to find. We're trying to find the value of it. So for our derivative, it goes away. For our last term, we have to reorder that. Remember, if you have an x on the bottom, in order to flip it up to the top, you can make the exponent negative. If it was negative, you could flip it and it become positive. If it's positive, you could flip it, it becomes negative. So we're going to have plus b times x to the negative 1. So it was to the positive 1 on the bottom, but we can write it to the negative 1 on the top. So whenever we go to finish solving this negative drops to the front, multiplies to the b, so negative b, x, and our exponent now decreases by 1. So we were at negative 1, now we're at negative 2. It's going to make this a little bit trickier to solve, but that's okay. So I'm going to rewrite this just to make it look a little nicer. Negative exponents can flip to the bottom and become positive. And this is our derivative function. We've got, this is our slope, our gradient, x value at a point, so this is the gradient at a certain point x, and b is a constant value. Since we know a point and the slope at that point, so we know when x is 6, it has a slope of 77 over 6. So I can plug that information in. This is my slope, so that goes in over here. for my f prime of x, my derivative. My x value is 6. We're saying at the point 6, it has a slope of 77 over 6. Now we can simplify this a little bit. So 77 over 6 equals 12 minus b over 6 squared, which is 36. I'm going to subtract the 12. Sorry, I'm running out of room here. So I'm going to subtract the 12 on both sides. $77, you guys like to use this button, which is great. 77 over 6 minus 12 is 5/6. I'm going to multiply both sides by 36. Actually, I'll do a negative 36. That way the negative cancels with that one, and then the 36's cancel here. So multiply by negative 36. So I already have 5/6 in there, so times negative 36, which is negative 30. So b equals negative 30. Awesome. I'm going to take the information that I have now and plug it all back into the original and see if I can find my a value. So my original function is here. So I've got f of x equals x squared plus a plus b is negative 30. I could have put minus. This will be all right, though, over x. They also, in the problem, gave us a point that's on the line. So the point 632 should be on the line. It's this slope at this point. So this point on the line has this slope. So I can plug in my x and my y value in order to solve for a. So my y value is 32. X is 6. Oops. There we go. X is 6, so both places where there was an x, I put a 6. Y is 32, so it's equal to 32. We're going to solve for a. This is 36 plus a. This will be minus 5. 30 divided by 6 is 5. Put my like terms together. 32 equals 31 plus a. Subtract the 31, and a is 1. So we found a and b. Once again, double checking is always a great idea if you have the information to do that. So I'm going to take my a and b value and plug them back into the original function and see what happens. So we've got x squared plus a, so plus 1, plus b is negative 30. Use this, negative 30 over x. Graph it. Who knows what this is going to look like? Something crazy, I'm sure. Okay, so it looks like that. I'm sure there's a lot more going on if we zoom out, but I don't think we need to. Let's make sure the point 632 is on our graph by going to the table. Check. Yay, 632. And then I want to make sure at 6 it has a gradient of 77 over 6. Now, 77 over 6 is 12.833. So that's what we should expect. So I'm going to calculate number 6, which is our gradient, our slope. When x is 6, enter, and there it is, 12.8333, which is what we said 77 over 6 is. So this works. All right, this should get us all the way through Chapter 12. Your homework over the second part's a little bit shorter, and it's available on Canvas. So get started on that next, and thanks for watching.